Okay, so what we have here, so now we are starting on section 3. This would be slide 83 in your PowerPoint and also chapter 3 in your PDF. I suggest having the PDF open for these, mainly so you can follow along and make note of maybe, it's like I'll give you an example here. Like right here it says, when major elements change, validation shall be performed. That's only for class 3. So the book is more detailed, but we also don't need to regurgitate every detail to you, just for this, learning method. However, that information is available in your PDF of the book. Okay, so we are starting on 3.1. This is talking about materials. Materials and processes shall produce acceptable products. I think that's kind of a given, right? But when major elements change, validation shall be performed. Again, that's only for class 3. So what it's showing us here, let me see if I can get my pointer to work. Yeah, I can. So this goes from stencil print, pick and place, reflow oven, and right here, this looks like this process changed. It used to be inline cleaning, but now it's gone to a no clean process. Something like that would have to be validated that the change in process would still provide an acceptable quality product. So that's what they're talking about with this, and that's only for class 3, I believe. Let me verify that before I say that again. Yes, it is class 3. There's no requirement for class 1 and 2. So when specified, manufacturers shall have a lead-free control plan, PB. This is the elemental, the table of elements. What's it called? A periodic table. This is the symbol for lead. For the control plan established between manufacturer and user, again, this is the person who builds it, manufacturer builds it, and the user is the customer. These documents right here, these standards will provide guidance on how to implement a lead-free control plan. This right here, if you can see, it looks like a little white line, like it almost maybe a little scratch. That's actually a tin whisker. When they're lead-free, there's more tin. And it tends to kind of have like little whiskers, like little fuzzy lines in the solder. There is a link here in this that you can go to check out more if you really want to learn more about tin whiskers. So when we're working with flux, there shall be a documented process to control materials that, not really working with flux, but we're working with flux, with solder, really any kind of materials that age, torque strike paint, epoxy, anything that has a shelf life. It's referred to as shelf life. There shall be a documented process for shelf life to prevent using products that have degraded past their age of usability. This is a requirement for, I believe, for class 2 and 3. Yes, it is a requirement for class 2 and 3. Limited shelf life items shall be stored and controlled in accordance with the material manufacturer's recommendations or in accordance with the documented procedures for controlling shelf life. The reason you do this is because say if something's only good for about 3 years before it gets kind of gross or not usable, like that flux. I think that flux that we have is kind of old and it's real sticky. I need to order more flux, actually. I need to just replace that. We have a lot of it, but I just need to replace it. And it gets to where it's not as a quality product to work with, and you don't want to use that in your producible product. Materials shall be processed per the manufacturer material specification. Materials should not be used within the pot life. So pot life is if you're mixing epoxy or a paint or something that has like 2 parts and it has to be paint mixed and then used, that it has what's called a pot life. So say if you have to use that epoxy within 1 hour or 6 hours before it starts to harden or starts to lose its potency, and it wouldn't work. you would need to use that within that lifetime. So a lot of times, they'll make you document, yes, I mixed this epoxy at 10 a.m. and I discarded it at 1 p.m. Or it was used, and it was, discarded in the hazmat bin or whatever. When curing conditions, what the heck? No, go away. When curing conditions vary, they shall be documented and available for review. So if for some reason your temperature went up in your room, or humidity increased, or any kind of, maybe the oven was, just calibrated or approaching calibration, they shall be documented and available for review, just in case there's something wrong with it later, or if there's a problem, or if they need to investigate what happened, that you need that documentation. Items exposed to uncured silicone shall not be used for other material. So, if you have like a pot or a cup or mixing materials that are used, like mixing tools that are used just for mixing silicone, they should not be used for anything else. Silicone will cross-contaminate anything that you try to use, and so you need to keep the silicone separate. Solder, so now we're on 3.2, talking about solder. Solder alloys shall be in accordance with, IAW is in accordance with J Standard 006. That's it's like a supplementary document. Other alloys may be used if all other conditions are met and objective evidence is available for review. Solder paste shall be in accordance with J Standard 005. And flux that is part of solder wire or preforms shall meet the requirements of Section 3.3. Preform, for anyone who took the wire harness class, that is a solder sleeve. That is called a solder preform. I think we'll talk about solder sleeves, I think in Module 2. Yeah, I believe that's Module 2. I don't think it's in this one. I think it's Module 2. So, lead-free solder. Solder alloys less than 0.1% lead, not listed by J Standard 006, may be used when the use is established between the manufacturer and user. Lead-free processing shall be in accordance with the documented procedure that includes controls to minimize the risk of cross-contamination. Solder baths, so solder purity maintenance. We're in 3.2.2. We're at the bottom of this first page here of Chapter 3. The solder baths shall be analyzed, replaced, or replenished in accordance with Table 3.1. Frequency shall be adjusted based on historical data or monthly analyses. And so tin, lead alloys other than 6040, 6236, 2% silver, or 6337 shall be within documented limits. So these are your standard, the 6040. So it's 60% tin, 40% lead, 6337, which is I believe what we use. That's 63% tin, 37% lead, and this is tin, so 62, 36, and with a little bit of silver. I want to say I know that there's a certain application that would require the silver, but I can't think of what it is right off the top of my head. So if you are using an alloy that doesn't one of these three standards, it should be used within documented limits. So Table 3.1, if you look in Table 3.1, there's no slide for it, but if you want to look at that in your PDF, if you know how to read a table, you'll do well on some of these tests as far as like some of these questions go. We'll go over this a little bit more, before the test on Thursday. But so like we're looking at the contaminant. Let's say I want to pick iron. I want to know the maximum limits in my solder bath for iron. So sorry about that. I got my headphones shut off for a second. So I'm looking for iron, and I want to know the assembly maximum contaminant weight percentage limit for tin lead alloys. So I go to the second column in the table, and I go down to iron, which is Fe, and I see there's 0.02%. You may have a question on the test about this, so just get familiar with the table and pay attention to the notes. Notes are always important. So then you we'll go over these actually before the test tomorrow. Solder purity and maintenance, dross, which is the crud that sits on top of so if you have a solder pot, we have a solder pot actually in our class. What the crust there's a crust that sits on top, stuff that's cooled and it's been exposed to the cooler air. It's called dross. For class 2 and 3, it shall be removed from the solder surface in a manner that ensures that the dross does not contact the items being tinned or soldered. That dross would be considered FOD, even though it's just dried solder. It's crusty, it's gross, it's kind of dirty. It has all the contaminants that are sitting on the top, and it needs to be removed. Okay, so flux. Flux is in accordance with J Standard 004. Flux shall be the activity levels of L0 or L1. They're rosin, resin, or organic. Flux OR L1. So the L0 and L1, those are the activity levels. They're called activity levels. OR L1 shall not be used for no clean soldering in class 2 and 3. So if you look at this table, you have your low, so like flux composition is rosin. If it's a low activity, residue activity level, that would be L0. High, so it would be ROL0. So RO, rosin. L is your low, and it's 0%. So it's less than 0.05%. For L1, it's actually less than 0.5%, and that would be ROL1. Other fluxes may be used, but they shall be available to make sure, again, that it's not going to affect the fit, form, or function of the product. Previous qualifications can be used, and type H or M fluxes shall not be used for the tinning of stranded wires. H and M fluxes, that would be for all 3 classes. The high and moderate activity for tinning of the wires, it can cause your wires to degrade quicker. So flux application. So this is external flux. You see he's using the paste flux. This person is using paste flux. And then you have flux cord solder. So we have flux cord solder. But we also do have the, actually I did get new solder. I think it's flux cord. Now I have to check. When an external flux is used with flux cord solder, the fluxes shall be compatible. In fact, I'm wondering if I'm pretty sure that's the problem with the flux pens that I have. I don't think that they're compatible fluxes. And you can look in Appendix C or C section 1.8.9 for objective evidence to make sure that that the fluxes you're using are compatible. Adhesives. Adhesive materials should conform to a document or standard such as IPC SM 817. The adhesive selected shall not be detrimental. Again, you do not want to put anything on your product that's going to cause it damage. The material shall be cured in accordance with manufacturer instructions. And additional criteria, we discuss it a little bit more in sections 10 and 11. Chemical strippers, solutions, paste, creams shall not cause damage or degradation. Again, don't use anything that's going to damage your So again, sorry about that. I keep having some problems with my audio here. Oh shoot. I'm trying to turn up the volume. It's just going through my slides. Neat. So with chemical strippers, they shall not cause damage or degradation. Again, we don't want anything that's going to cause damage or degradation. And I know that they don't want you using pastes, any kind of chemicals strippers on stranded wire. That the solution, the chemical can get kind of sucked into the wire and into the strands and cause degradation internally. Component and seal damage. This is a badly burnt, looks burnt. Yeah, that's pretty burnt. Minor surface flaws are acceptable. What we're looking at is not a minor surface flaw. Flaws like, little scrapes or kind of chips or something, they shall not expose the component substrate. So the bottom, the middle or lower layers. Components shall not be charred, unlike this picture. Damage shall not degrade the components below parts requirements and fit form or function. So I mean, if there's like a little small defect, as long as it's not going to affect it, it should be acceptable. But something like this is a picture of a very obvious defect. Lead seals shall not be degraded below the part specification requirements. So what this picture is showing us, we have metallization. So this is a surface mount. This looks maybe like a capacitor or a resistor. Metallization is the application of this like metal film and on the side, and that's where we solder to. So if there could be metallization loss on one side or on the top or on the end face, you see these right here. This is where it's just it's gotten thin. Metallization loss shall not expose ceramic on the terminal end face. So this right here, this is probably then a defect because it looks like the ceramic's right there. It should not be greater than 25% of width or thickness on any termination side. Again, that's pretty big. This as well. Be 50% on top of a 5 or 3-sided termination component. And I mean, that's kind of bad too. I would say that would probably be greater than 25%. Tools. I want it darker. There we go. I want a little bigger. There we go. So now we're talking about the coating meniscus. This is what I mentioned briefly yesterday. This is meniscus. This right here. This is the meniscus. This did not work. Okay. So the meniscus, there we go. And this meniscus has been trimmed. That's why it's shorter. That would be a defect for class 2 and 3. Tools and equipment shall not cause damage. I would hope that would be kind of obvious. Okay. Shall not cause damage. Soldering irons and systems shall provide temperature control and isolation from electric shock or thermal shock. Appendix A, that does talk a little bit about the tool selection and maintenance. It's calibration, how these things are kept usable for continued use. And tools used to cut leads shall not impart shock that causes damage. Okay, so that is section 3. Let's go over review questions real quick. I'm going to pause for about 10 seconds after you look at the question to see if you can figure it out. So when ORL1 flux is used for no clean soldering, what do you think that condition would be? So that is organic, low-level solder. Right? Yeah. Oh, I'm sorry. So level 1, so more than 1%. Slide on. Oh, no, module 3. I had the wrong slideshow up here. So that would be back. Where did that go? So flux. Let's look in your PDF. So this is an example of like when you have the PDF open, you can look up the word, ORL1, you can look up no clean soldering. That's in section 3.3. It says right there, flux ORL1 shall not be used for no clean soldering, but it's not a requirement for class 2 and 3. For class 1, sorry, it's only a requirement for class 2 and 3. So it would be N1, D2, D3. Guidelines for tool selection and maintenance shall be used. I know that was just talked about for just a second. If we go back to section 3.7, see Appendix A for guidelines on tool selection and maintenance. Also, when Appendix A is specified, that is when we use Appendix A. The maximum amount of aluminum contaminant as a contaminant in an SAC 305 tinning solder pot is, now this is when you would refer to table 3.31. Go down under contaminants and look for aluminum. That's a few lines, like 5 lines down. Now if you look at the top, you have preconditioning maximum contaminant weight, assembly maximum contaminant weight, and then preconditioning and assembly maximum contaminant weight percentage limit, SAC 305, solder-free, lead-free alloys. So you're working in an SAC 305 tinning solder pot, you're working for lead-free, so you want to look in that column under aluminum, and we see the answer is 0.006%. That's a very, very small amount. Which of the following flux types can be used for tinning a stranded wire? This is one of those questions, you'll see these every now and then, where it's basically almost like a process of elimination. We know when they talked about flux, if you look under 3.3, it says type H or M fluxes shall not be used for the tinning of stranded wires. So we can eliminate these two right away. This one can be eliminated, and this one can be eliminated. You're not supposed to use H and M's. Oh, and this one can be eliminated too. So what's left? A. The Rollo. In major elements of a proven process are changed, guidance for validation of the acceptability of the change can be found where? We're not talking about, we haven't really mentioned 610 really all that much, and that's not what we were talking about. So we know it's an appendix. So let's look to see if we can find where this appendix is mentioned. Let's try the very beginning under 3.1. I know it's 3.1. Where is it? Let's see. Okay. Oh, there it is. It's in the second paragraph, I believe. Yes. One major elements of the proven process. So now what you could do in your PDF, you can search the word proven process. You can look for, even if you want to start looking what appendix A, B, C is, see if it's in this chapter anywhere. So if you did search for the words proven process, it would have brought it right up. I'm looking at the actual hard copy book, so I don't have the cool search function, just my eyeballs. It's the second paragraph. So when major elements of the proven processes are changed, flux, solder paste, cleaning media, solder alloy, soldering system, validation of the acceptability of the changes shall, for class 3, be performed and documented. See appendix C. So it is C. There we go. I'm going to pause here for a second let's see, we have stopped quite a bit. Actually, you know what? I'm going to make the rest of this another video. So I'm going to post this one that I've just completed, and then I will post the rest of it. It'll be another short one. It'll be probably like 20 minutes maybe. Okay? All right, thanks.